application. I think it's, I'm not sure. I mean, it appears to me that it's not an embedded system, no?
No, it was more a network.
So it's like a general purpose application.
Yes.
Okay. Mm, yeah, maybe I think if you can explain me in more detail, so what's inside
I can share my screen and show the code I've
yeah.
written. Do you think that's okay?
Yeah, please go ahead.
Can you see?
Yeah, okay.
Someone is making noises. I don't know if it's not muted or something. Now it's not.
Okay.
Okay, so I wrote 4 actors. The one's called central, one called agency, and then the sink and the source. I don't know if I got the concepts correct, but like the sink and the source, I just provide some inputs, and basically that will be connected to the agency.
You don't have to show me the code. I mean, it's not important right now. I mean, the whole concept. Maybe open the network here.
Okay.
Yeah, that's
It's a bit messy. I couldn't find a way to like rearrange the arrows. It generates the arrows and then I cannot move them apparently. So it's like impossible to see how things are connected. Is there a way to modify it?
I mean, you have to delete the connection and just simply I mean, you have to then again put the connection.
I see, but I cannot choose the path that the arrow will make.
Yeah, I mean, sometimes it gives warnings. I mean, are you getting an error?
No, I don't get an error, but when I try to run the simulation, it gives the one Java error. I took a screenshot error. Just wait. It takes some time. This error, when I try to simulate, it doesn't give any more detail than that.
I mean, have you tried also other benchmarks that are there in the repository, like addition and simple ones?
Oh, yes.
And they are working fine?
Yes.
Okay. Maybe, I mean, I would suggest that then do it step by step. I mean, divide the whole network into segments and then simulate them step by step so that you know that at this stage and you know error appears.
I see. Okay.
But it's okay. I mean, for now, I mean, it's not important that if it's
But
working.
I have a question because you say that the actor should not have guards.
I mean, what I mean to say is, of course, we are going to have actors with guards, but if each actor has guards, then we cannot create OpenCL code.
Okay.
What I mean to say that we have to write a code in the manner that we can write also actors without guards and without state variables, so that we can also generate OpenCL kernels. Because in the end, if we could not generate any OpenCL kernel, then it doesn't make sense, you know, to use the framework.
I see.
Then we would like to use the ORCC framework only because they only exploit task level parallelism. So what we want to do is also to exploit data level parallelism using OpenCL.
Yes.
So I mean, this is important. Writing the benchmark right now. I mean, you're going to do that in the next phase as well. So you will get a lot of time to do that. Yeah.
But
Yeah.
I noticed that you say that you shouldn't have a guard. So I removed the guards and I have an if inside the action, but I have state variables. That's a problem.
Um, I mean, the if statement is the same thing. I mean, the guard is, so what you're doing right now is, so you're also kind of using a guard, with this if.
I see.
So what I mean to say is that we don't need to have, a control flow inside the actor where we say that if this, then do this.
Mm,
We have static actors. So by static, I mean, so in each execution, it consumes and produces fixed number of tokens.
mm-hmm.
But I mean, we don't have to write each actor without guard. Yeah, of course, we are going to have actors with guards as well. We cannot avoid that. But what I mean to say is that in between, we also need a number of actors without guards that for that we can create. I would then again suggest to look at the criteria that we have for the framework. How we generate OpenCL code. There is a criteria.
Mm-hmm.
Look at that paper that it's in the literature folder. Look at the paper, and there is this algorithm that we use for generating OpenCL code. This will give you an idea that how, I mean, the main idea of writing these benchmarks is not just to write, a benchmark for the sake of, developing an application, but also to write it in a manner that we can, we can evaluate performance in the end based on our framework as well. And for that, we need to create OpenCL kernels. We need to generate. So the idea is while you write these benchmarks, you have to write them also, having that in mind that I have to write these benchmarks with actors that are simple. I mean, not in terms of computation, but in terms of construct. Like we don't need to use guards in every actor.
Mm-hmm.
We need,
So control flow.
yeah, I mean, simple ones, but maybe maybe computations. Yeah, more instructions, set of instructions, but less constructs of CAL language. Like we don't need to use state variables. We don't need to use maybe just single actions. We even don't need multiple actions.
Mm-hmm.
Not for every actor. Yeah, there will be some actors where if you want, you can also use guards. You can use state variables. You can use action schedule, multiple actions, whatever you want. But it will be in between. Try to use. We have to write these benchmarks sensibly in a way that we can, also target our framework, how our framework generates code. But I mean that this is important. That's why again I would suggest that have a look at that criteria. That's in the paper. That will give you an idea that I mean the only I mean, the reason that we are writing these benchmarks, I mean, the other option is, of course, to use the ones that are already there in the ORCC repository. But if you look at these benchmarks, these guys have written these benchmarks to match their framework ORCC. So they are only exploiting task level parallelism. And if you look at these benchmarks, they do not offer a lot of data level parallelism, or they do not offer static actors. I mean, mostly they use guards and state variables.
Mm-hmm.
Now we have to kind of write code that would match our framework, the code generation of our framework. So that's one thing to keep in mind while you write these benchmarks. But again, I mean, at this level, I would say that we need to discuss the abstract idea of the application. What is the application? Um,
Thinking about because I thought that maybe this first idea I had wouldn't be good, and I was thinking maybe I could implement some cryptography algorithm.
Oh, yeah, that would be fine as well. I mean, I'm not sure about this system. You call it post system or something like that, yeah?
Yeah.
So it's like keeping track of the post deliveries and stuff like that.
Yeah, but I think it's better if I go for an application that the control flow is more like one way because the way it is right now, like it has multiple errors for all directions. And I think I want to try something that has one input, one output, and like several actors in between that do heavy calculations. for example. I think that will work better.
One input, one output shared. I didn't get it.
Because the network I have now, it has several inputs and several outputs, and the control flow is quite complicated. So
Mm,
I was thinking maybe to try to find an application that has only one single input and one single output.
yeah,
And
but I think it doesn't matter. Even if you have a lot of inputs and a lot of outputs, then again, I mean, it's not necessary that we need to use guards for every actor.
mhm,
We can have applications where we can, read inputs from all input buffers and do some calculation in every execution. So
mhm,
without looking into the values of inputs, we are just performing computations. So I think it doesn't matter if you have more inputs and outputs. I think that would be better. But somehow we have to think of an application where we don't have to perform computations based on the values of tokens.
mhm. Okay, I can develop the idea and then send you an email today or tomorrow. I don't know. Are you going on vacations today or?
But I mean, it's okay. I mean, you can. I mean, during these vacations, I will be available by email, so it's fine.
Ah, okay.
But as I said, I mean, now we are going to enter the next phase, which is the development phase, and in this phase, you're going to develop these applications, these benchmarks, and you also have to evaluate. I mean, it will last for 4 to 6 weeks. Yeah. So you have time for making these benchmarks and evaluation.
Mm-hmm.
Start from today. Yeah. But I think it's fine. You thought of an application. I mean, it looks fine to me. The only concern is, of course, that it doesn't look like an embedded system. It's more like a general purpose application, and normally in such applications, performance is not that important.
Mm-hmm.
So even if it takes more time than required, then it's fine. I mean, it's a very soft kind of application. I mean, soft real-time application.
Mm.
But also, we don't have to write hard real-time applications. I mean, I would say I mean, I mean, the idea of using a kind of a cryptography and algorithm and stuff like that, I would say will also be fine. But have a look also at, I mean, the domain of IoT also, so stuff like that. Because there you can get, I mean, what is important is, I mean, what I liked about this application also is that there are multiple, these central processing units
Mm-hmm.
you have, and then you can easily grow your network by increasing these central processing units. So you get the idea, right? I mean, we need something like that will allow you to,
Scale.
yeah, that will allow you to grow your network quite easily.
Mm-hmm.
So you can just copy paste, these blocks in parallel.
Mm-hmm. I get the idea.
Yeah, yeah. So that's fine. But only that to keep in mind, whatever you think of as an application, also keep in mind the criteria that we have to follow for writing these actors and actions within actors. So again, I mean, you don't have to write each actor, without guards, and you can use multiple actions, whatever you want to use. But in between, try to, also add some actors which we want to have.
Mm-hmm. Okay.
Okay. Yeah, that's fine. I think you got the idea now. I think you can now go ahead with the development phase. Okay. So what about Levi? Do you also want to discuss your idea? Levi, do you hear me?
Yeah, I can hear you now. Um, Hello?
Yeah. So have you worked out your benchmark? I mean, idea.
Yes, I also I checked out something that I was thinking about as well.
Mm-hmm.
It's basically on temperature control system.
Mm-hmm.
Then let me see if I can share the screen.
Yes. Yes. That will be good.
Mm.
Maxim and Ego, can you hear me? Okay, yeah, please stay on the line. So I will come to you after, Levi, okay? No, please wait. I mean, I will come to you after Levi. I will come to you after Levi, okay?
Where do I share this screen?
So there is a monitor symbol there at the left side. On the left side or at the bottom, you see there's a monitor symbol.
Okay.
Just click that.
I don't know why it's not working. It seems not working for me.
Mhm. Maybe you can send me an email, or I mean, if you have a figure or something like that,
Okay.
send me my email, and then you can tell me what it is.
Okay. Okay, I just sent the email now to you.
Okay.
Have you gotten it?
Not yet. Waiting for it. Yeah, I got it.
Okay.
Okay, yeah, I can see it now. You can explain it what it is.
Okay, basically, the idea is a kind of temperature control system,
Mm-hmm.
taking for an instance an apartment, and so maybe depending on the number of rooms within an apartment, so we have the heat devices in each of the rooms, and then but basically, firstly, we have like a central control unit that controls the devices in each of the rooms and the heat devices in each of the rooms, and then for in those rooms there is a sensor, temperature sensor, and we have to like put a kind of values, or maybe the degrees that it should not go below or not go above. Then those sensors, they have to communicate to the central unit. The central unit has the actuator. So once it dictates any degree, like any of the rooms that seems like the temperature is less than the required or what is supposed to be, then the actuator triggers the device, and the device works to stabilize the temperature in each of the room. So like it could work for a whole building. It depends on if I can develop it and then see how to expand it to more than one apartment.
Okay, yeah, there are two questions that I want to ask. First is,
Okay.
um, yeah, as I discussed it with Louisa as well,
Mm-hmm.
do you think that you will be able to write kind of actors without guards and state variables with such an application, then is it possible?
Mm,
And maybe first thing would be, so each room that you mentioned here in the block diagram,
yes.
is it going to be one actor or is it going to
Yeah.
be a network of actors?
No, each of the block diagram should be one actor,
Mm-hmm.
and then the main actor, like inside all of them that are actors, then the central control unit is like the main actor here, while other actors are being controlled by the central control unit.
Mm-hmm.
Mm. So, but I think there will be guards, but
Mm-hmm.
I don't know.
Yeah, I think the idea is good because again, you can quickly, grow this network depending upon the number of, so you call it rooms, yeah. But
Yes,
this is one apartment.
yes, yes.
Yeah, I think you can also extend it to maybe,
Building.
also a building where you
Mm.
have multiple apartments, so you can grow this network quite easily. That's good. I mean, these actors that you have for heat device, which you call the heat device or temperature sensor, uh, it does not check anything, or it simply provides data to the control unit, or it checks for some range, temperature range.
Uh, it only provides data to the central control unit, and yeah, basically it provides data to the central control unit. The temperature, the sensor gets the values and then forward it to the central control unit,
Mhm.
and the central control unit now sends trigger to the device as well.
Yeah, I think the idea is good, but I think you have to optimize it a little bit to to make it more complex. I would say because I think in the end it would become too simple. I mean, not at the network level, but at the actor level, you see that the computation would not be too much.
Okay, there won't be more actions.
I mean, even as you don't need multiple actions. You can use a single action, but inside that, maybe try to use add another parameter. I don't know. Apart from temperature, maybe use another one. Because in the apartment you can measure also other things. Uh,
Okay,
think about that. Maybe use some kind of algorithm to calculate this temperature. Don't assume that the temperature sensor is providing you
okay,
the exact value. Maybe try to use some algorithm to calculate that temperature, and maybe use some kind of other parameter that you can use a combination of both to calculate one value. So we also need some computations.
okay,
Otherwise, in the end, you're not going to see the change in performance a lot because with such simple actors, there will not be a major change in performance, even if you grow your network.
okay.
So I think the idea is good. Just try to optimize it with some more parameters, yeah.
Hmm.
Think in this direction. Maybe try to add another sensor or maybe try to add an algorithm which will allow you to calculate something.
Okay.
Maybe just inside a single action, that's fine. But we need a number of, number of instructions to do that computation.
Okay.
This would be my suggestion. But overall, I think it's fine. It's just like a single idea, but it's fine. I think this is the initial idea only. And then I think you can also extend it to the whole building where you have, multiple layers of these of
Hmm.
network.
Okay.
Because I mean, in the end, we need to evaluate performance and we need something substantial. Otherwise, you will not see a big difference in performance even if you are exploring data level parallelism.
Okay.
Yeah, so that would be my suggestion. I think it's fine. Yeah, just optimize it. Just make it more complex at the actor level. Just try to add more parameters, maybe one two more parameters.
Hmm.
Maybe use the concept. I don't know. It's just an idea. It's up to you. But maybe the idea of maybe water control system that I explained in the last meeting, something like that.
Okay.
That would allow you to also make the computation more complex. But
Okay.
it's good. I mean, I like it. Yeah, it's fun. So you have to work on that, optimize it, and you can go ahead, with the development phase. Now you have to make these benchmarks and write these benchmarks, and you also have to evaluate using both frameworks in the next phase.
Okay.
Okay. Yeah. That's fine. Yeah, as I also, but I think that we can discuss at the end of the meeting regarding what we're going to do during vacations. Okay, so let's now move to the next two. Maxim, you go. Yes. So, what about you guys? Are you done with your the installation and evaluation for the ZigBee connection? Okay, can you? I mean, you can you share with me that arrow or something, whatever it is? I mean, can you share your screen, something, show it to me? So the ORCC is working fine. So you have already generated the input and I mean the output. Okay. And you have some problem with